Very, very much. Good afternoon to all of you. It's a great pleasure to be able to talk to all of you patrons of the Blackstone Library. Now, a couple of things. Number one, uh, and everybody gets this wrong because you see three letters in a last name. I'm actually my last name is pronounced as if there were a Y between the A and the O. It's Rayo, not Rao, but don't worry, everybody makes that mistake. As far as what we're going to talk about today, we're going to talk about the seven wonders of the universe, which is a subjective, I should stress that, a subjective opinion, because there are seven objects that I've chosen in the sky that are readily attainable to us with either our unaided eyes, a pair of binoculars, or a small telescope. In other words, these objects we're going to look at this afternoon you don't need the James Webb or Hubble Space Telescope to see them. They're readily accessible to all of you, and we're going to be looking at them during the course of the next hour, comparing them to, at the end of the talk, the seven wonders of the ancient world and the similarities and differences there. One thing I would like to ask for all of you, if you can, if you've not already done so, mute yourselves so that there is no extraneous noise coming through your microphone and interfering with what I am saying. A lot of times I give talks, and sometimes you hear people in the background talking or chatting, or somebody drops something or whatever, and that could be a little bit disruptive to somebody who's giving a lecture like myself. So, and also the other thing is, from time to time during the next hour, you're going to hear me pause for a few moments. That's only because I will be wetting my throat with a little bit of Poland Spring water, lubricating my vocal cords, if you will. So now let's get going. We will. This is a PowerPoint program, and we're going to start right from the very beginning. I hope all of you can see the logo of this wonderful library that is sponsoring this presentation this afternoon, the Blackstone Library, and I thank them very much for inviting me to talk to all of you. So that having been said, let's get going. We realize, of course, that ever since mankind has walked the face of this planet, that he's gazed upwards into these beautiful nighttime skies, which sadly we very rarely ever see anymore because of light pollution. But he has enjoyed the sights, and in particular, he's enjoyed looking at some of the objects that he's found especially pleasing. In fact, it's been the custom always, and still is to this day. Oh, you should see what I saw last night. What was it? Where was it? Oh, I've got to look at that. And by the way, the next time you look, I want you to look at something because I really found a marvelous object in the sky. So it has been through word of mouth, through generation to generation, that people looking up into the sky have found magnificent objects to gaze upon, to follow, to enjoy as they looked into the nighttime sky. And there are objects beyond our ability to count, I suppose. Some of them truly stand out. Of course, the first and most important is a star, our star, the sun. What a wonderful object this is. It's a tremendously hot ball of gas, as we all know. The 864,000 miles across is the part that we see normally. All gas from its surface to its center, gas clear into its entirely hot central regions, 11,000 degrees on the surface, almost 30 million degrees at its center. Gas, nonetheless, all the way through. Gas so dense that the average weight of a small amount of it, a cubic centimeter of this, is heavier than the weight of an equal amount of water. The sun, compressed, hot, spewing out all forms of radiation out into space. And look at some of the magnificent photos that we've been able to view through the photographs that have been taken either by those who have orbited our planet or by satellites that have orbited our planet and have looked out into space at the various celestial bodies and again at our central star of the solar system, the sun. And look at that giant prominence that you see on your screens right now. That rising. Now, mind you now, the diameter of the sun is, just a about 100,000 miles shy of 1 million miles or so. And this thing must have been shooting out from the surface of the sun, the photosphere, going out into space almost 250,000 miles out, and almost as far as the distance between the Earth and the moon. That tongue of incandescent gas. And this is just an example of the. It's like a hydrogen bomb. The source of our heat and all of our light is due, of course, to the sun. If it were not for the sun, I don't know how many of you have ever thought about this, going outside on a bright sunny day or whatever, I'm looking up at the sun, but you come to realize that if it weren't for the sun, you wouldn't exist. I wouldn't exist. Nobody on this planet would exist. We rely on that giant gaseous ball of heat and light, 93 million miles from us, for all the life that's on this planet. And who possibly cannot marvel at the spectacle of a total eclipse? No spectacle that nature has to offer can rival a total eclipse of the sun for sheer drama and excitement. It's not just something that's seen, it's something that, well, those of you who have been fortunate enough to experience a total eclipse of the sun in your lifetime know it is an experience. Every fiber of you gets involved during those short moments, few minutes of totality. And if you have never seen one before, let me tell you right now that this is a bucket list event. This is an event that you should see before your time on this planet is up. And I might tell you that you may remember that back in 2017, there was much ado about an eclipse of the sun that crossed the country from one coast to the other. The first total solar eclipse to touch any part of the contiguous United States since 1979. Well, that was 2017. And if you didn't take advantage of that experience, I have news for you. In just a little over a year, you're going to get another chance. And I hope all of you, and we have 44 participants right now listening to this presentation of mine, I hope that every one of you 44 takes advantage of this event. It's coming your way a little over a year from now on Monday. Mark it down on your calendar. Monday, April 8th, 2024. A total eclipse of the sun is going to sweep from Texas through the Mississippi and Tennessee River Valley, up into the Ohio River Valley, on into the eastern Great Lakes, and into upstate New York and northern New England. Think about this now. There are scientists, there are astronomers who travel sometimes halfway around the world in order to position themselves in the path of the total eclipse, the path of the moon's shadow, to experience those few moments when the sky darkens, as you see here again on your screen. You're able to see the solar corona, the beautiful pearly white halo that always surrounds the sun, but is only visible when we knock out the entire disk of the sun, when the moon places itself perfectly in front of the solar disk and gives us this spectacular and fantastic view. Halfway around the world, people travel, and that yet a little over a year from now, all you will need to do is get in your car and travel north up to upstate New York or northern New England, Burlington, Vermont, Syracuse, New York, Buffalo, Rochester, Plattsburgh, New York. All of these places will be experiencing totality. And how many miles, how many hours away is that from the Blackstone Library or from your homes? 3, maybe 4 hours? You're going to have a total eclipse of the sun delivered to you, literally right to your door, a little over a year from now. And I hope, again, I strongly urge you, because it's nothing like you've ever experienced before in your life. And at the very beginning and the very end of totality, we have those magnificently beautiful diamond ring effects that grace our skies. They become indelibly implanted into your memory, and they remain a lifetime when you have been there where the shadow of the moon strikes the earth. Again, April 8th, 2024. Don't miss out on that spectacular event. And you'll be hearing more and more about it as we get closer to that event later this year, and especially as we move into early next year. And there are other objects too. Then there are the planets, mighty Jupiter. Oh, we've been able to look at that through photographs taken by spacecraft that have come up so close that have been able to give us just magnificent views, not only of Jupiter and the clouds that conceal its surface, but also of the amazing satellites that Jupiter possesses. And Mars, oh, Mars, right down through the ages. Mars, a fantastic object because of its ruddy color. Mars, then seen through the telescopes of the Italian Giovanni Schiaparelli in 1877. Mars with those lines, those lineations, called canali, translated canals, inspiring and exciting the spirit of man because canals, well, canals are man-made. Oh, intelligence on Mars, perhaps. And the markings that are seen through the telescopes, you could see this was an actual headline from the New York Times early in the 20th century. People actually thinking that there were inhabitants on the surface of the planet Mars. And the markings that are seen through the telescope, the white caps to the poles, the darker shades near the equatorial regions, sometimes actually looking green through the telescopes, and the changes that take place during the seasons. Oh, we've got to go there, said man. We've got to go there and find out what Mars is like. And, of course, the constellations. The Big Dipper, which I'm sure all of you recognize, 3 stars in the bowl, 4 stars in the bowl right up here, 3 stars in the handle. And at the end of the bowl, these 2 stars that you see here are the pointer stars. And if you're a Boy Scout or a Girl Scout or a campfire girl back in your earlier lives, you know that these 2 stars at the end of the bowl, when you draw a line through them and then extend the line out 5 times the distance between the 2 stars, comes to the most important star in the entire sky, Polaris, the North Star. And that star is located at the end of the handle of the Little Dipper. Little Dipper is much fainter than the Big Dipper. There's the bowl of the Little Dipper there, and there's the handle. Looks more like a meat cleaver as opposed to a dipper, but there's the Big Dipper, there's the Little Dipper. And other star patterns in the sky. How many of you were born under the constellation or the sign of Gemini, the twin brothers? And you could see the twins if you look real carefully enough. These 2 bright stars mark the heads of Pollux and Castor, the twin brothers. They have their arms around each other's shoulders. Castor is the one with the short leg, and Pollux is the one with the long leg standing beside him. And finally, one more constellation, and I'm rather proud of this picture because I took it myself. This is a photograph of the constellation of Scorpius, the Scorpion. And I took this picture from a most unusual spot. I took it from Easter Island, the middle of the South Pacific Ocean, no land for thousands of miles surrounding us. But I led a tour to Easter Island back in April of 1986 in order to get a good view of Halley's Comet. Yes, Halley's Comet. We all remember the appearance of Halley's Comet, and maybe some of you even saw it back in 1986. The Scorpion, formed by these 3 stars, the claws of the Scorpion here, and then winding down to this bright orange red star, Antares, marking the heart of the Scorpion, and then the Scorpion winding down to this fishhook shaped star pattern, which marks the tail. And right here, these 2 stars are the 2 stars that mark the stinger of the Scorpion. So there's the Scorpion. This bright star here, and we'll talk about it in a few moments, is not really a star, it's a planet. The planet Saturn, which in April of 86 was located in the constellation of the Scorpion. And can you see Halley's Comet? Halley's Comet is in this picture too. Can you see it? Can you find, wait a minute, way down over here, there it is. That's Halley's Comet. Now, your grandparents or parents may have told you how in 1910, Halley's Comet was a magnificent object, and it was. Back in 1910, the comet came within 13 million miles of the Earth, and the tail stretched across more than half of the sky. But in 1986, the tail and the head of the comet passed more than 4 times further away from us in space. And so Halley's Comet was not much to look at in 86. There you see the head. There was kind of a weak fan tail over here, but still people wanted to see it because of so much that they had heard about it over the 75 or 76-year time span that it's visible. And so many people traveled south of the equator in 1986 to try to get as good a view of the comet as possible. Well, as I said, there it is, not much to see, but there it was for all to see back in 1986. By the way, the comet is going to be much closer and much brighter and more spectacular than it was in 86 when it comes back again. And all of you, I want you to take note, if you're still around, the next time the comet will return will be in the midsummer of the year 2061. That's a little under 40 years from now. Good luck to all. Keep taking your vitamins and do a lot of good wishing, but so it goes. And the clouds of stars that exist above us, every speck of light that you see in this photograph is a sun. And who knows whether or not any of them have circling round about them planets, possibly to harbor life. The imagination goes on and on as we look into the sky. The color cameras that enable us to see things that the mind of man could only guess before color photography came into being. Example, what you're seeing on the screen now is the North American Nebula. Here you see the east coast of the United States. Here's Florida. Here's the Gulf of Mexico. Here is Mexico. And here's the west coast of the US. North America, the North American Nebula. Now let's see what it looks like when we add color to it. Oh, look at that. Beautiful, beautiful view. And of course, the dark clouds that lie beyond it, obscuring the stars that lie beyond. Oh, this is a universe, and it's yours, you know, a universe of excitement and beauty. There are stars in the Pleiades star cluster, wrapped in veils of gossamer blue, magnificent beauty, and you can see that beauty early in the evening, now, from Connecticut, from New York, from the tri-state area. Those 7 stars are plainly visible high in the southern sky as soon as it gets dark, looking like a little cloud or a little fuzz of light until you look directly at it, and then you can see those 7 stars in the constellation of Taurus the Bull, another star pattern of note. The bull marked by a V-shaped pattern of stars called the Hyades. There's Aldebaran, the angry eye of the bull. And beyond, outside of the field of view, 2 bright stars marking the tips of the horns of the bull. And why is the bull so angry? Well, when I give talks at the Hayden Planetarium, especially to youngsters, I say, well, there's a good reason why the bull is angry, because he has 7 bumblebees stinging his back. Of course, to the ancients, they weren't bumblebees, they were 7 maidens, the 7 sisters riding the back of the bull as he romps through the wintertime sky. And in this sky, there are veils, draped not only through the stars, but veils for the shoulders of a queen of the sky, or any fair lady for that matter, veils for her shoulders and rings for her fingers, and roses for her hair. A magnificent universe is ours. There are great lagoons in the sky, through which mythical canoes can be paddled. Lagoons giving birth to stars in tomorrow's skies, and helixes twisting and turning. Stardust, every bit of it stardust, ashes of a star blowing away the outer layers of itself out into space. There are owls lurking in the sky, and tarantulas creeping across the deep southern sky. Oh, even a dumbbell here and there. What beauty! What beauty! A sombrero to shield you from the searing rays of the sun by day, and whirlpools that catch you up and sweep you into your imaginations, into the vastness of the universe that is yours. It's a magnificent sky. There are even quasars out there, recently discovered, sending forth radiations, unbelievable amounts and jets of gas rushing outward from them. Quasars, unknown. What can they be? They are not generally visible with the eye. We find them using the great radio telescopes that gather in from space radio energy, similar to light energy, but different in wavelength, gathering in that energy and then compacting and condensing it and causing it to activate a series of pens that move up and down as a piece of paper passes beneath the pens. From space, scribblings, and the men of radio astronomy reading these messages from space and enabling us to determine the nature of the sources of such objects that send such radiations to us. Yes, wonders, wonders, wonders. But of all the great and wonderful objects that are out in space, what could we choose as the seven most remarkable objects, seven objects that can be available to us, either with, as I said at the start of this program, either with just your naked eye or with a simple pair of binoculars or a small telescope, seven objects that could be called the seven wonders of the universe. And first among these, in my opinion, and I'm sure you will all agree, is the face of the moon. Oh, gaze upon the face of our natural satellite, the great dark regions, the maria, the seas we call them, though we know that there's not a single drop of water there ever, the craters, the mountains, the rays streaming forth from some of the craters. Exciting, exciting, exciting. Close up, through the telescopes of man, we see the Sea of Rains, Mare Imbrium, and over to the upper left of that region, a crescent-shaped domain of beauty, Sinus Iridum, Bay of Rainbows, one of the truly delightful objects to be viewed through a telescope as we look to the moon. And to the right of it, there's a crater with a very dark, smooth floor, which we have named for Plato, the great philosopher. And straight down to the south of it, another crater, this time with a lighter shade of gray, the crater Archimedes. And then as you go down to the left at the end of a chain of mountains, we see Eratosthenes with a mountain right in the middle of the crater. And over there, down at the bottom of the view that we have here, is the monarch of the moon, Copernicus. Well, here again, Archimedes. And you see the areas where it appears that at least liquid rock has flowed to form these smooth-looking basin floors, and the other craters nearby, and the mountains that are at the edges of the great seas. And here it is, Copernicus, there on the face of the moon. Perhaps one of the most magnificent photos that we have ever been able to take from this planet Earth toward our natural satellite was taken at the Lick Observatory out in California. And over to the upper right of it, Eratosthenes, and directly above Copernicus, the mountains of Gay-Lussac, and directly south of Copernicus, a little crater looking like a keyhole. South, a mile deep, south. Oh, there, it's a wondrous part, and you can see the streamers of brilliance extending outward from that crater in all directions. Beauty, the rays coming from the monarch of the moon. Then, of course, before we started sending man to explore the surface of the moon, we sent explorer satellites like Explorer and Surveyor, who took pictures, these satellite, robotic satellite pictures that were taken in the 1960s. And here we see a view of Copernicus. There's Falk down here at the bottom, looking over that 62-mile wide basin with the mountains in the middle, to the terrace far walls, and to the mountains of Gay-Lussac far to the north, and then closer still, now looking down almost directly above the rim of the crater, down into Copernicus, to those mountains over 5,000 feet tall in the middle, to the walls 10,000 feet in the distance, to the mountains another 10,000 feet. In 1966, when this photograph was taken and published, Time magazine called this photograph of the century. At least it was in 1966, photograph of the century. Ah, but the moon is a barren place. No bugs, no blade of grass, no sound, no air, no rain, no ice, no snow. Nothingness, nothingness, nothingness. And yet, ironically, that nothingness that was there, attracting the spirit of man like nothing else that has ever been, beckoning man, come to me, come to me, come to me. And man went. And those of you of a certain age, and I find it difficult for me to believe that over a half a century ago, on a memorable late July night, a Sunday night, the 20th of July in 1969, more than a half a billion of us on this planet, all looking at our television screens and watching as a man started down a ladder until finally he put his boot down and pressed it into the dust of the moon. And there, man had finally made contact with another planet. Man on the moon. And that footprint that is there, still to this very day, unchanged, because think about it, there's nothing to remove it, nothing to change it, nothing to blow the dust or to spoil it. And in fact, unless possibly on the small chance some strange erratic meteoroid or projectile from space would have crashed down on this site and obliterate it, it could be 1,000,000 years from now. That footprint will be just as fresh as it was the day it first was planted by astronaut Neil Armstrong there on the face of the moon. So we went there, 12 all told, 12 Americans walking, cavorting on the face of the moon. 2 by 2 we came in the Apollo space program. And they brought back moon rocks, moon rocks, filled with beauty. For the moon rocks containing among various ingredients, beautiful little beads of glass, baubles from the moon, beads that are red and golden, blue and black, crystal clear and yellow, every color of the rainbow. And where did they come from? You saw those rays extending out from the surface of the moon. Projectiles from space, crashing into the rock of the moon. The heat of impact vaporizes that rock. Up it goes. Then quickly condenses into little droplets of liquid that form their spherical shape. Freeze immediately they do, not as crystalline material, but as glass. Beautiful, shining baubles of glass covering much of the surface of the moon, brought back here to Earth by the men of the space age for us Earthlings to enjoy. Yes, certainly a spectacular sight. And you may remember, if you were out and about on Election Day morning last November, when the moon traversed into the shadow of the Earth and provided us with a view of a total lunar eclipse. The moon at totality glowing like a reddish ember, a reddish color caused by our atmosphere. The red color of sunrise and sunset refracted or bent into the shadow of the Earth and then moved forward into space onto the face of the moon as the moon passed through the shadow, causing this amazing sight of a ruddy colored moon. It was a beautiful sight to see. And again, I would think that all of you will agree that certainly number one on our list of the wonders of the universe, another view of the lunar eclipse, number one on our list of the wonders of the universe, the face of the moon. For number two, I've chosen the rings of Saturn. Oh, now, I don't know how many of you have actually had the chance to see Saturn's rings through a small telescope. I have done this many many, countless numbers of times over my more than 50 years of being an assiduous amateur astronomer. I did this most recently last October at a gathering of the Westchester Cerebral Palsy Society. They had an outdoor gathering of people, and they said, "Would you bring your telescope to show us the sky and the stars?" And I said, "With pleasure." And Saturn was out that night, and people were lined up looking and with amazement. And it always is the same thing when they look at Saturn, same type of exclamations. "Oh, no way," or "Awesome." In fact, one woman, and this usually happens, she looked through the telescope and then she turned to me and she said, "Joe Rayo, I'm surprised at you." I said, "What?" He said, "I'm surprised you're trying to fool all of us." He says, "That's not Saturn." I said, "It isn't?" He said, "No, you've got a slide of Saturn in there. That cannot possibly be." I said, "Madam, yes, it is Saturn. If you have a good telescope and know where to look up in the sky, train it on Saturn and you will see those beautiful rings." Oh, it's beautiful indeed. Again, I don't know how many of you have had the opportunity to look at Saturn through a small telescope, but I tell you, the next time you get a chance, be sure to look through they appear like they're glowing on their own, but actually they're not solid, but rather they are composed of countless bodies ranging anywhere from microscopic dust specks or flecks to boulders and mountains, maybe as high as wide as 20, 30,000 miles across, all circling around Saturn, where possibly a moon in the distant past came too close to Saturn, and Saturn's gravitational pull ripped the moon apart into shreds of objects that we see now encircling the planet, about 10 miles thick. And you can see during the course of our year around the sun, as we go around the sun in our orbit, and Saturn in its, it takes 30 years for Saturn to go around the sun. Periodically, we can see the top half of the rings, then the bottom side, and in between, there comes a period of time when the rings are turned directly toward us. And when that happens, and it will in the spring of 2025, just a couple of years from now, when that happens, even telescopes, the biggest of telescopes, cannot see the rings when they are turned directly toward us. Then Saturn looks like it has no rings. Right now, the rings, if you were to look at it through a telescope, and right now you can't see it actually because the planet Saturn is in line with the sun, and so the brilliant sunlight is obscuring our view. But when it reappears later on in the spring and returns to our summer and autumn skies, you look through a telescope, this more or less is going to be what you're going to be looking at. You'll still be able to see the rings, not as wide open as they were some years in the past, but you'll still be able to see the rings. And again, in 2025, those rings will be turned edgewise, and you won't be able to see them for a few months because, again, they're so thin, 10 miles thick, and we're looking at Saturn from a distance of almost 1 billion miles away. But very exciting, nonetheless, because when the rings are turned edgewise to us, it gives us an opportunity to view some of the satellites of Saturn. Saturn has about 82 satellites, believe it or not. And sometimes when the rings are turned edgewise, we make discoveries. In 1966, the arrow is pointing to this little blob right here, this little dot. That was satellite number 10, Janus, which was visible once the bright light from the rings were eclipsed by the edgewise effect of Saturn through the telescopes. And again, Saturn is not visible now. It's visible, it will be visible again when we get into the spring and summer months, when it is first in the morning sky, and then in the summer, you'll have to stay up until about midnight before it rises above the horizon. And by late summer and the fall, you'll be able to see it in the early evening. And again, if you have a telescope, be sure to point your telescope toward it to see those rings. Now, this view of Saturn and its rings were taken from the Cassini spacecraft, which orbited our the planet Saturn. But I want to draw your attention in this particular photograph. Again, this was a spacecraft that was right up close to Saturn. And I want you to take a special look at this down over here. This little dot, I hope you can see it. See that right there, right off of the left side of the outermost part of the rings? That's a little dot. Doesn't look very important, very impressive, but that dot is you and me and everybody else who lives on this planet. That is the planet Earth, as seen from the Cassini spacecraft about 1 billion miles away from our home planet. And when this picture first came out back in the 1990s, the late, great Carl Sagan, probably one of the greatest American astronomers, at least of the 20th century, he looked at that and put it all into perspective. He wrote, from this distant vantage point, the Earth might not seem of any particular interest, but for us, it's different. Consider again that tiny little dot. That's here. That's home. That's us. On it, everything you love, everything you know, everyone you have ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of competent religions, ideologies, economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king, every peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, and we've known a few in recent years, haven't we? Every superstar, every supreme leader, every saint and sinner in the history of our species lived there, right there, on a mote of dust suspended in a sunbeam. That is us. That is our home planet. It doesn't seem like very much, but to you and I, it is the most important thing in the universe and the most important thing in our lives. So that was number 2, the rings of Saturn. Number 3 is a constellation. We saw a few earlier, Scorpius and Gemini, the twins. Now gaze upon the most beautiful of all, and which is readily available to you tonight or any clear night for the next month or two in our southern and southwestern skies after sunset. That is the constellation of Orion. None other to compare it with, really, in our skies. Orion, looking like a huge box with 4 stars making up the torso of the hunter and 3 stars making up his jeweled belt. And you can see hanging from the belt another 3 stars here. And look there at that reddish glow, the gleam of the sword, the great Orion Nebula. A cloud of gas is there in a region dominated not only by the brilliant stars that we see, but by gas. Here is the great nebula. And what a remarkable thing this is. Beautiful to behold. Now, when you look at it through a telescope, this is a long exposure photograph that brings out the colors. When you look at it through a telescope, you don't see this red. You see more of a greenish gray, basically. But all the long exposure photographs from the great observatories bring out this beautiful red and blue and multicolored face of this cloud of gas that is there, so very large that it would take 26 of our years to go for a beam of light to go from one side of it over to the other, traveling 11 million miles every minute of those 26 years. And it's not just that it's a cloud of gas. You may say, all right, Joe, it's a cloud of gas. Okay, yeah, it's pretty, it's nice, but what's the big deal? But it's more than just a cloud of gas. Here we see a photograph that was taken into that cloud. The year was 1947. William Harrow, George Herbig, 2 astronomers, taking this photograph through the big 200-inch Palomar telescope out in California, taking this photograph, 3 patches of light embedded in the gas. 1947. 7 years later, in 1954, same astronomers, same instrument, same type of film, looking at the very same patch in the sky. But look what has happened. The upper patch and the one down to the right have doubled. 2 stars born in that cloud of gas during the lifetime of many who are viewing this presentation right now. And other similar regions are now in this cloud and in other similar nebular clouds out in space. Yes, These clouds are the incubators of stars, new stars being born right before us, clouds that will blow off the excess gas when they fully radiate all of their energies, clouds that will shine in tomorrow's skies for future generations to see. Yes, magnificence and excitement in the region of Orion, and the gas and the dust and the strange grotesque shapes like the horse head, so near the junction of the belt with the sword of Orion. And that dark area is not really a hole in the gas, it is actually cosmic dust, obliterating or obscuring any starlight that may lie beyond that dust cloud. And other gas too, clouds of carbon monoxide within this region of space, tremendous clouds. Yes, Orion, the mighty hunter, who is now high, high in the southern sky at nightfall, and you can see him if you step outside on most any clear night. First thing will attract your attention is the three stars that make up the jewel belt, followed by the four stars that make up the body of the mighty hunter. The three little stars up here marks the beard of Orion. His head is empty space, but you can see him now. He is the keystone, the benchmark of our wintertime star patterns in our sky right now, and certainly number 3 on our list of the wonders of the universe belongs Orion, the mighty hunter. As the 4th on our list of wonders, the Milky Way itself. Oh, I hope that most of you here have seen it. You know, we used to see it regularly. 100 years ago, even some of the skies, big cities, back then when the skies were not as bright and as dazzling as they are now, well, what can I say? No longer. For the wonderful lights of man, and who would complain about them, nevertheless has taken away some of the vistas of some of the glories and objects that we have in our sky and can see with our unaided eye. But when we're at sea, or when we're on islands far, far from most of the habitation of man, or up on a tall mountaintop, or in some rural area, far, far from strip malls and bright lights and unrestricted parking zones that are lit all night long by bright lights. When we're far away from bright lights and when we can actually see the stars in all of their wonder, then we get a chance to see that glorious band of light as it arches across our sky. What is that band? Starlight it is. Stars so numerous that they form not individual specks, but they merge together and form that band of light, which again we have come to call the Milky Way. Stars beyond our ability to count, I suppose. Literally dozens of billions of stars, literally hundreds of billions of stars, billions of stars that are all out there in space for us to look at. As we gaze into the Milky Way with binoculars or small telescopes, you can see the haze or the band of light broken down into individual stars. The artist has drawn our galaxy here for you to look at. The large, vast cloud of stars, of gas, of dust, with two smaller companion galaxies, the Magellanic Clouds, seen in the skies deep down to the south, and the great globular clusters that are strewn around it like lighthouses. A top view and a side view of our home. We are located where you see the circle in this view here, or the circle over here, located about 2/3 of the way out from the center, from the far edge of the main part of the Milky Way galaxy, not including the halo that extends far, far beyond that which is shown. The galaxy itself on this view here, shaped like two dinner plates, one put upside down atop the other, and the great dark cloud of interstellar dust located between them. Yes, the Milky Way. And every star that our eye can see as we look up into the nighttime sky is part of the Milky Way. But the glow itself contains the bulk of the stars, but no matter in which direction we're looking, we can see neighbors to our sun, other stars in our particular region of our home galaxy, the Milky Way. As the fifth of the wonders of the universe, a part of the Milky Way, the great globular collection of stars seen in the direction of the constellation of Hercules. Now, can you imagine for a moment what it might be like to live on a hypothetical planet near the center of this literal globe of countless stars, maybe as many as 100,000, all jammed together into this one central region? My goodness, on a hypothetical planet such as that, the stars would probably glow so brilliantly, there wouldn't be such a thing as a night. There would be day and night, but the night would be illuminated by countless brilliant stars up in the sky. And the stars, these globular clusters, are, as I said a few moments ago, arrayed in such a way that they are like lighthouses shining around the center of the Milky Way galaxy itself. Magnificent objects, and objects that will be studied intensely in the years to come, I believe. For here's a question: what happens to stars when they're so closely packed together? What goes on within them? What takes place in the midst of the globular clusters? For again, they're not flat spirals like the galaxies themselves, but rather giant globes of starlight in the sky. And what happens when stars so closely packed together collide with each other? Are they colliding? Will we ever be able to see spicules of light and energy bursting forth suddenly when stars crash and annihilate each other? What is the story of matter within these globular clusters? What new lessons will be ours to learn as scientists today and tomorrow study these weird, strange balls of stars in our sky? The Great Hercules cluster is probably the most notable, the most noteworthy, the most significant, and the most obvious of all the globular clusters visible to us from here in the Northern Hemisphere. And in fact, you see it here as it would appear in a reasonably large telescope, still the central part of the cluster unresolved, but outside you see individual stars outside on the edge or the rim of the globular cluster. It's in the constellation of Hercules. This is a summer constellation. So during the summertime, if you look high overhead, and if you go away from any bright lights, you'll be able to perhaps make out Hercules as a kind of out of balance quadrilateral in the sky, which is known as the keystone, if you will. And along one side of the keystone, right there between these two bright stars, you see the cluster. With binoculars, it appears as a dim circular patch, but in good telescopes, you can see again that cluster of what is estimated to be about 100,000 stars in the sky. Number 5 on our list, the Great Hercules Cluster. Number 6, the Crab Nebula. Oh, here is stardust. It was the 4th of July. The 4th of July in the year 1054 AD. Astronomers in China and in other parts of the world as well, including here in the southwestern part of what we now call the United States, looking into the sky early that morning at a lovely thin crescent moon coming up just before the sun. And then suddenly, to the right of the moon, shining suddenly in the sky, was a star. What an amazing star this was, shining forth, getting brighter and brighter and brighter, until within a matter of days it became so bright that it was visible to the naked eye, even during the daylight hours itself. For 2 months, it shone forth and then began to fade. For 2 years, it remained visible to the unaided eye, and then just as mysteriously, it faded out and disappeared. Fortunately, the men who saw it and observed it those many, many centuries ago carefully noted its position in the sky. And today, as you see here on this petroglyph, this is from a cave in the southwestern United States. Whoever drew this drew the crescent moon and then drew right next to it this dazzling, brilliant star that appeared in the sky. And I suppose that's the handprint of the person who did the artistry here. But today, when we look to the location of that strange guest star in the sky, we see this. Tentacles of incandescent gas streaming outward, as it were, from the location of a star who apparently, at one time in its history, blew itself apart. What a catastrophic explosion that must have been. Nova, said the men of old, new star. Well, no new star that. Actually, that was a dying star. And in the throes of death, the star blows itself apart, suddenly becoming literally hundreds of billions of times brighter than it ever had been. And now today we look toward that location and we see again this cloud of gas. And right in the middle of that cloud of gas, we see one bright little object, one bright star in the midst of this cloud. And, you look at it and you say, well, what can that be? Well, astronomers, when they first started looking at it many, many years ago, said, oh, it's a pretty little star. That's what we thought for a while. But then later, when we started observing with our radio telescopes, we noticed there was pulsations of radio energy coming from it. Actually, the whole thing started right here in the United States when radio astronomers from Yale, looking into the evening sky, even as though you and I saw the stars twinkling beautifully. Oh, they said, the stars are twinkling. Now we know why they're twinkling. That's the atmosphere. During their trip toward the planet Earth, the starlight, way, way out in space, the beams of light from that star travel toward us straight and true. But then when they interact with our turbulent atmosphere, the atmosphere kind of mixes the starlight up to a degree, causing the starlight to scintillate or twinkle. Twinkle, twinkle, little star. So that's the reason why we see the stars twinkle at night, is because of the atmosphere. But then radio astronomers began to say to themselves, we wonder if in any way we have twinkling of radio waves caused by our atmosphere from space. Unfortunately, there was no radio telescope up until about the mid-1960s that were able to pick up any such twinklings. But then over in England, Anthony Hewish and Jocelyn Bell had created their own radio telescope, and they had sensitized it. That is, they were able to reduce the background electronic noise so that they were able to pick up in their radio telescopes fainter and fainter sources of radio energy. And as they looked toward an object like the Crab Nebula, they found pulsations coming from there. Bing, 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 bing. Little pulses of radio energy. Pulsar, they call them. And there are many, many of such pulsars now that are noted and seen in the sky. But that wasn't enough, because when the men of the space age began to put spacecraft into orbit with sensors to pick up on ultraviolet radiation, they turned those instruments toward the Crab Nebula, and look at what they got. Bing, 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 bing. Ultraviolet radiation from that star within the Crab Nebula. And then, after further study, X-ray radiation was detected. Bing, 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 bing. All the forms of radiation pulsating at 30 times per second from that star in the middle of the Crab Nebula. Does light also pulsate? Well, 30 times per second, that's persistence of vision that negates our ability with our two eyes of being able to see such pulses visually. But this remarkable series of photographs shows quite clearly, here's a bright star here in the far left picture, and to the lower left of that star, we see a fainter star right there. But now look, in the next photograph, the fainter stars gotten a little bit brighter. And now in photograph number 3, both stars are almost the same brightness. In number 4, maybe the star to the lower right is as bright as the upper left star. And again, in the first 4 photographs, we saw the star suddenly brighten. And then, just as quickly, that lower right-hand star fades until finally it's gone. And then it starts to appear once again. And it does this over and over, 30 times per second. The light energy from that amazing star in the center of the Crab Nebula. A neutron star, they said. Whoops. Here we go. Let's go back to that first thing. A neutron star, they said. Almost dead, spinning violently, just a few miles in diameter. This star at one time was a star maybe 10 to 20 times larger than our sun, and now only a few miles across, but all of that material that was in that giant star has now been crushed and compressed into that much, much smaller core of what was once that massive star that existed out in space, which later exploded. And how dense is that compression of material? If you were able to take a teaspoon of gas from that particular object and bring it here to the Earth, that teaspoon of material would weigh literally hundreds, yea, thousands of tons. Gas, teaspoon-sized. And that's what's out there in this cloud of gas now, the Crab Nebula. An amazing object, a remarkable object, seen in the center of the midst of that cloud of gas, the remnants, the smoking gun, so to speak, of a tremendous explosion that took place, again, maybe 6,000 years ago. And that's how long it has taken the light from what was a giant star, which has exploded, to reach our eyes and are visible today as the Crab Nebula. And finally, for the 7th object in our list of the wonders of the universe, a neighbor of ours in space, the great Andromeda galaxy, a galaxy that's visible in the constellation of Andromeda. I almost feel like Mr. Rogers when I see the great Andromeda galaxy. I say, "Hi, neighbor. Hi, how you doing?" This galaxy that you see on your screen now is the closest of the major galaxies to our home planet. Only, he says, 2.5 million light years away. Now, how far is that? If you were able, and here's another view of it through the great Hooker telescope out in California. In fact, Edwin Hubble, well, let me go back just a moment here. In the sky, when you see this galaxy, and yes, you can see this galaxy with your bare eyes without any use of telescopes or binoculars. And if you see it in a nice dark sky, you see it as an oval or a patch of light in the sky. That's all it looks like with your 2 eyes. It looks even a bit tired, but again, you got to understand, the light has been traveling out in space toward us for about 2.5 million years. And we thought for a long time that this object was a part of our Milky Way. We used to call it, in some of the older astronomy books you would see, they called it the Great Nebula, the Great Cloud in Andromeda. The first person to ever see this object was a gentleman, his name was Al-Sufeh, who lived out in the Middle East in the 10th century, and he called it the Little Cloud, because that's what we thought it was, a cloud. But then in 1923, Edwin Hubble, the same guy whose name is now attached to the famous space telescope, Edwin Hubble took a photograph, and the photograph showed something most interesting. It's not a cloud. No, it is another galaxy, just like the galaxy that we live in. He broke it up and was able to show it not as a cloud, but as individual stars. And there are also bands of interstellar dust, just like what we have here in our galaxy. And as I said, it's located at a distance of 2.5 million light years, one of the closest of the major galaxies to our Earth. Now, just to give you an idea of how far away it is, if you ever walked down the street, and if there was such a thing as $1 million bill, and you looked down and you saw $1 million bill on the sidewalk, pick it up, put it in your pocket. Congratulations, you are an instant millionaire. That's great. But if you wanted to be a trillionaire, and we see trillions of dollars mentioned so often when we talk about the budget of the United States, if you wanted to be a trillionaire, you would need 1,000,000 of these $1 million bills. That is the equivalent of 1 trillion. Well, light from a star takes 186,000 miles per second moving out into space. In 1 minute, that light beam has traveled 11 million miles. And in 1 year, that light beam has traveled 6 trillion miles. Now, in astronomy books, when we talk about distances to stars and to galaxies out there, we use a celestial shorthand. We use the light year, not a unit of time, but a unit of distance. You see, if I were to tell you right now that the nearest star, Alpha Centauri, is 4 1/3 light years away, that, if translated into miles, would be 25 trillion miles. 25 with 12 zeros attached to it. And don't even ask about galaxies. We'd fill half the book with zeros. So we use light years instead. That is why we use the term light year. So when we use light year to define how far away the Andromeda Galaxy is, we say it's 2.5 million light years away. Well, take out that calculator and multiply 2.5 million by 6 trillion. And the answer, unless you come up with an error message on your calculator, the answer is something on the order of about 15 sextillion miles. In other words, 15 with 17 zeros after it. That's how far away the Andromeda Galaxy is. That's the closest to us in space. And you see the center of the galaxy here. By the way, that galaxy is twice as large as our galaxy. It contains 800 million, maybe even 1 trillion. There's that number again of stars as compared to our own. And there are some galaxies that are out there that we have looked at that are literally tens of millions of light years away. And in fact, we've actually seen objects all the way out to what you assume is the beginning of our universe. Near the edge of our universe, the beginning of what we call the Big Bang, 13.8 billion light years away. Tremendous distance, tremendous size. And again, on our list of the 7 of the universe, wonders of the universe, we certainly need to have this object, the great Andromeda Galaxy. And so we have seen the 7. Like the 7 wonders of the ancient world, they shine forth to us in the sky. But unlike the 7 wonders of the ancient world, these 7 objects will remain on and on and on. For of the 7 wonders of our planet, the 7 man-made wonders, only one remains: the pyramids and the Sphinx of Egypt. But no more can we find the hanging gardens of Babylon, which once were so magnificent. No more will we find the golden statue of the god Zeus, for it's gone, gone forever. No more will we be able to find the beautiful temple that has been built to honor the goddess Diana, destroyed, ruined through the ravages of time and man. Gone forever, the tomb of King Mausolus, from which we get our name Mausoleum. Gone forever, the mighty Colossus of Rhodes, no more to be seen. Gone forever, the 7th of the ancient wonders of the world, the great lighthouse of Alexandria. Yes, ladies and gentlemen, these objects that we have put down on our planet, magnificent but temporal they. But the wonders of the universe that we have just spent the last hour looking at, the 7 objects, the 7 wonders of the universe, will remain. The face of the moon, the rings of Saturn, the constellation of Orion, the great Milky Way galaxy, the great globular cluster in Hercules, the Crab Nebula, and again, the galaxy beyond the group of stars that we call Andromeda, the great Andromeda galaxy. Yes, folks, these are the 7 that have been selected by yours truly as the 7 wonders of the universe. And that is it. And I thank you again for spending the last hour or so listening. And if you have any questions or comments, you can either put them on the chat board, or you can, better yet, unmute yourselves and just ask the question of me directly, and I'll be very happy to try to answer them. But again, thank you very much for spending part of your Sunday listening to our talk on the 7 wonders of the universe.
Thank you for your enthusiasm.